Welcome back, everybody. So good to have you here again. With me now is Marc Blasco from Steinert, and he will talk a little bit about metal recycling, what they can do, how they do it, and yeah, how you can do it with their machines as well. Marc, so nice to have you. I don't want to take any of your time, so let's get right into it. Have fun. So good to have you.
So, hello, thanks, Felix. I'm Marc from Steinert, and today we will talk about metal recycling, um, about automatic sorting from the past to the present, and we will use a little bit particular example, which is electronic scrap. Let's start being honest. The past sucks and the present is boring. I am in this business for over 17 years now. And even from before, I studied industrial engineering at the Polytechnic University of Catalonia. I still remember the first scrap recycling plant I have visited nearby Barcelona around 2005. At that time, um, it was considered somehow rocket science what they were doing there. There were no pictures allowed, restricted access. Exciting and sophisticated technology was used in that plant. Yes, absolutely exciting. And please note my irony mode. There was a stunning Meva QZ chain cross-flow shredder, a Mogensen sizer screen, one magnet for ferrous, and a lot of hand pickers, as you can see here. So not even an eddy current to sort the non-ferrous metals. 10 years later, the average plant had more technology which I was already trying to sell in 2005. Over the last years, an e-scrap plant is producing, thanks to automatic sorting technology, more materials than it did before. So basically, the very basic layout from 2005 would be a part of what we can see here. So the shredder, a magnet getting out the ferrous, screening, and not even eddy current. They had hand pickers here, that's it. Over time, for sure, eddy currents were the first incorporated technologies in the sorting of the electronic scrap, and they were basically producing Dolbar, and that's the end of it. Stainless steel, copper wires. This was hand-picked, and that was the end of the story. Around 2000, later on the time, it's not that it started in 2010, for sure not, but it's when this kind of plants were more standard. So the start of using induction sensor technology to create the Zurich. The Zurich, we understand, is the stainless steel and the insulated copper wires. And then for sure on the rest, there was plastic, which was sold to plastic recycling companies as a plastic mix. So not a big deal, since most of the materials were mixtures, and it was sold to third companies which were doing further refining of the materials. Luckily, over time, a few years later, it became more complex, but it made for sure more intermediate products. So we started to use sensor sorters with color detection and shape detection to sort out the PCBs. There's something it's much better to do at the beginning of the line, because otherwise the PCBs get spread over all the products in every different step, because they are magnetic and for ballistic several reasons. So it's much better to concentrate them at the beginning and create a single product and forget about them. At that time, Dorber used to still be the end product on e-scrap sorting plants, and they focused on recovering better dysteric and creating nice stainless steel and cable concentrates to sell as the raw materials, and then the sorting of visible plastics with near infrared. It's something which became also a standard and normal procedure in parallel, for sure, with wet processes. The diagrams I'm showing here, for sure, not ideal or not even typical concepts, but they are basically trying to make a resume of how can I say that, the kind of products we can obtain with which kind of technology. So it's a very simplified thing. So getting ABS, PS, for example, PPE, but never from black plastics, which, by the way, are the main color over the last years on electronic devices, electric and electronic devices. Some customers even started to go further in the sorting with the Zorba, and basically, maybe Felix, you can show us here a video of a plant we did in Switzerland, which is
Marc, you will have to unmute your microphone once again so we can hear you.
Sorry, I was okay. I don't know what you mean, but that's a plant we made some years ago in Switzerland. At that time, it was state of the art. Today, it's not something we overtook the process conceptually sorting. That's the right one. That's the right one.
Oh, okay.
Let's see. Technology different from different products. Sensor for metal sorting. So we sort different products like circuit boards, PCBs, cables, and plastics. We concentrated all this heavy stuff, and the drop, which is basically plastics, went to the near-infrared machine to sort all visible plastics. So black plastics go further, but then we could produce ABS, which are so aware of all of that time.
Wait a second, Marc. I'll just restart the video for a second, sorry, because it seems there might have been an issue with them hearing you. Maybe you can try again. Wait a second here. You can unmute yourself once again.
Okay.
Just
forward. Should they repeat something or?
Maybe you can get another input from the chat. Hear you now.
to sort all heavy things, means PCBs, cables, and halogenated plastics. This came from the drop of eddy current. So this is afterwards sorted, and the remaining plastics are going to near-infrared technology, our UV sort. And there we sort all visible plastics, not the black ones, which are not visible with near-infrared. And we use ABS, ES, and then there is the drop. This was sold in picture. Further prepared product. And then from the drop, we produce glass. With this machine, we are now able to differentiate then in this case, they were running the machines in parallel. Product, which means at the drop we have all the visible all the visible plastics which are not polyolefins or styrene. We created this black plastic product, but which can be further processed with another technology we have now to differentiate within black plastics. And now comes the part which I think is interesting, which is the processing of the Zorba, so the metal product of the eddy current, which can run on X-ray transmission and produce clean and wonderful product. So it can actually go to a smelter for using in this case secondary. Of the sorting, but always with the single target. In that time, we sorted copper, glass, gray, metal by color. Over time, we found out that this was not a most efficient way to do that. It was the available technology in this time. Now you can skip the video. And we can continue with the presentation. Perfect. I share my screen again. Yes. So basically, that's what we are doing today. Most of the plants coming from our video. So sorting PCBs with the KSS concept, getting rid of them at the beginning, producing a Zorba, so a metal, non-ferrous metal concentrate, which can be further processed and X-ray transmission, creating a clean aluminum product, and then the heavies I come later on to this part, and the rest with induction center sorters or with the same machine KSS, we can create this Zurich, which is the metal, the concentrated metal product of the drop of the eddy current, which is basically composed by stainless steel and insulated copper wires, which can be separated among the order with the KSS, creating nice end products, and then with the plastics using the near infrared that we have seen in the video to create mono fractions or mixed fractions of the plastics. Luckily today we can even go further away. That's why I say it's in 2021. We can use X-ray fluorescence to create pure, real heavy metal products like copper, brass, zinc, nickel, whatever, really based on chemical analyzed and with X-ray fluorescence and not by color, which at the end very often is leading to false results. This is a big step because then you are really producing end products which can be directly sold to a furnace. So we are producing furnace-ready materials and extrusion-ready plastics, and that is what is interesting in here. Nevertheless, plastics in electronic scrap are basically, or most of them are black plastic. So with near infrared technology, it's not possible to separate this, but at Steinert today, much more is possible with our technology, with our broad product range, and we have the right technology to sort black plastics, or let's say all plastics, whatever is the color, according to if it's polyolefins, PP, PE, we can isolate PP, we can isolate PE, ABS, PS, PC, PVC, and others. So we can now create these nice products from electronic scrap and really close the loop. So in the past, what we expected from a scrap sorting plant was basically to get ferrous out, to get non-ferrous, make a plastic mix, and with some hand pickers or later in time with center sorters to create some kind of ceramic or stainless steel and cables materials. That's over, but the existing, as I say in the slide, the existing state-of-the-art technology from Steinert is today paving the path to close the loop. Today, we can much better obtain the products which the market is requesting. So we still produce the old products, which is basically ferrous and the non-ferrous and so on, but we go deeper in developing this materials and sorting them, and we create really in the market, that's what the market is requesting: aluminium, copper, brass, zinc, even precious metals, gold, silver, palladium, nickel, this kind of things we can sort with the X-ray technology, especially with the X-ray fluorescence technology. And this is really amazing, the results we are obtaining, nice pure materials. This is ferrous, this is zorba, this is etheric containing PCBs, this is a plastic, visible plastic material. Today, among this, we can even make nice pure aluminum, wonderful pure stainless steel, pure copper, pure brass. We can create black plastics, but even sort them among them. And nevertheless, the market requests as well within these plastics from the scrap. They must be free of allergens, free of chlorine, free of bromine, and we can do that. We can make this clean polyolefins, PE, MPP, and we can make a nice styrene fraction without any brominated plastics between them. Like in some countries, like in France, we are not able to sell the styrenes if we are not making a guarantee that there are no flame retardants on them. Maybe now, Felix, you can play the video again. This is a very nice video showing us our
X-ray fluorescence technology enables an advanced separation of mixed heavy metals. Due to exposure to X-ray at a certain energy level, metals emit characteristic spectra, which enable their separation into, for example, copper, brass, and zinc. This effect can also be applied to concentrate valuable metals such as gold and silver. Bell sorters, such as the KSS-XFL, are most suitable applied to the separation of heterogeneous materials with regard to their particle size and shape. Chute sorters operate with higher efficiencies when the properties of shape and particle size are more homogeneous.
Maybe we can play again.
The next step is the separation.
Sorry, Marc, I was unable to understand you during the video.
Sorry. Okay, maybe you hear everything, but I do not hear anything at all. So that's why I'm asking.
you didn't hear. The video was visible and hearable to anybody, but it's very loud.
They can hear the explanations, and the video are really great, so I do not need to explain anything.
Yeah, so I just show the video. Let's go.
Yeah, X-ray fluorescence technology enables an advanced separation of mixed heavy metals. Due to exposure to X-ray at a certain energy level, metals emit characteristic spectra, which enable their separation into, for example, copper, brass, and zinc. This effect can also be applied to concentrate valuable metals such as gold and silver. Bell sorters, such as the KSS XFL, are most suitable applied to the separation of heterogeneous materials with regard to their particle size and shape. Chute sorters operate with higher efficiencies when the properties of shape and particle size are more homogeneous. The next step is the separation of a copper product out of a heavy metal concentrate. Due to the coarse and wide size range, this material is processed on a bell sorter. An efficient material feed distribution is a key factor for a successful sort. The material in feed happens via a vibrating feeder that transports the material onto the belt and distributes the objects evenly in transport direction. As seen in the previous video, the material extraction is done by compressed air bursts. For the ejection, pressures of up to 10 bar can be used in order to remove even the heaviest objects. This could be, for example, large copper items. The copper product can exhibit purities of up to 99% and can be applied as feedstock in smelting facilities without additional processing. Along with copper, zinc and brass concentrates are common sorting products out of heavy metals. In addition to the detection of base metal alloys, X-ray fluorescence enables the recognition of surface coatings. One example are nickel or chrome-plated brass items used in bathroom appliances. These can be identified efficiently according to their specific surface characteristics. In the field of heavy metal sorting, the CHUTEC allows an efficient sort starting at particle sizes of approximately 4 mm. The material is presented to the detection area and the extraction occurs after moving over a steep chute. The material is therefore not scanned while being positioned on a conveyor belt, but in flight after the chute. The distance between detection and material surface thereby remains constant, independent of particle size. Especially in the particle size range below 20 mm, the CHUTEC has a strong advantage, due to the detection in flight and an advanced sensor resolution. The development of this system is a significant extension to our X-ray fluorescence portfolio. The addition of this processing line in the test center is most valuable in finding the most suitable solutions. The material shown here even has a size range of 3 to 15 mm. It is fed into the process using a magnetic vibrating feeder to create a constant and even flow. Ejection system in this case is also a valve bar. However, here the standard valve grid of 12.5 mm has been completed by adding a second grid with a spacing of 6.25 mm per valve to be even more flexible and efficient for the finest material. The result is a copper concentrate and a rest fraction which predominantly contains brass and zinc. These products can be separated in additional processing steps.
So I think I am back. Show my screen again. Oops. Okay. So you've seen this video. I think it's really state of the art today. What we can really achieve with this technology is still impressing me a lot. We can create all the products I was explaining here and refine them and even focus a lot on the heavy metals. The video was not with electronic scrap, but it's absolutely applicable to the same. And for here, say 2022, I'm just going to finish soon. Basically, we can even do more refining, and we can do the sorting of the halogenated plastics with the X-ray fluorescence technology. So with the unit sort black eye, we create, for in this case, the stearins fraction, so ABS, BS, and sorry. Traditionally, we've been using in the industry, we've been using dense metal separation to get rid of the brominated and chlorine plastics. But it's proven that very often it's not enough to reach needed qualities because a considerable amount of light halogenated plastics remains within the light fraction of the float and sink. But luckily, with the X-ray fluorescence, it's been proven that it can be a solution. Actually, there is pictures from just a few days ago. Plastics from electronic scrap, even some PCBs are still there. Look at this. It's very easy to see. This is with the handheld. The brome, high brome content on these plastics. We run this through the XRF sorting machine, and simply it works. So we can really use the XRF machine to create nice heavy metal fractions, and then on another shift use the same machine to clean and produce nice ABS and PS that you can sell into the market without the issues that probably you might have today when you try to sell this. And last but not least, we opened our new test center some months ago. Now it's even bigger than in the picture because we added another sorting line here, but it is a very impressive facility with all the machines we have, all the available technologies, where you can really run industrial scale tests. You can bring your big bags of material, your arm material, and try, check all the possibilities, the feasibility with your materials, and then look at the results. And then based on this, we can design together a process or a solution for your needs, and even create some performance guarantees for the process to make you feel safe before going further on the project and buying our equipment and incorporating it to your plant. Just to finish, so basically that's the sorting ideas that we have and we want to use for a world of infinite resources.
Marc, I've got to stop you there. I'm really sorry, but our time is
basically
a little bit
basically I wanted to let you tell us that we have this chat room now where I'm happy to answer questions.
Yes, you can just head over. I just posted the link in the chat, and there Marc will be able to answer your questions in person. You can of course head over to their booth. And with that, I've got to say thank you, Marc. Bye bye, and see you soon.
Thank you.